G'day Internet, my name is Andrew Russell and welcome to episode 43 of GameDev Coaching. Now if this looks like my talking head up against the default Windows 7 wallpaper, it's because we're doing a re-record, or I'm doing a re-record. So unfortunately the hard drive that was running the system decided to go and explode or something. It doesn't work anymore, and so unfortunately 3 episodes have been lost, and I'm going to now basically talk through what Daniel and I did in those episodes based on the notes that I still have. So I had reasonably good backups, so I've got all the notes, but all of the video recordings for those 3 episodes were lost. So keep good backups, kids. Anyway, let's get down to it. So in this episode, what we basically did, it was an opportunity to do a little bit of revision for how the separation system works and the separating axis theorem. And basically I talked through what we wanted to do, and what we wanted to do was add a hover mode. So when we hover over a shape, we get what's known as picking. So we figure out which shape is being hovered over. So there were 2 steps to this. So the first step was, all right, let's draw the shape being hovered over, and that's simple enough. So fortunately, I do have some code that I'm pulling. So I'm actually using Daniel's version of the code here because he keeps his vaguely in version control and I don't. So we're sort of playing fast and loose and got bit slightly, unfortunately. So just searching down. Okay. So somewhere at the bottom of the draw method, what we're going to do is we're going to make a loop for all of the shapes. In fact, okay, so this is one thing we touched on during the episode, and that is how to draw the topmost shape. So our shapes are like, shape 0, and then shape 1, and then shape 2, and we place them. And we want to highlight shape 2, so the topmost one. And so how do we do that? We want, well, let's start by just highlighting all of them, and then we'll come back to what we need to do there. So shape 1. So and then we're going to go up here and we're going to grab the shape drawing code, and we're just going to replace it here. And so the way this worked was we're just going to draw them in green over the top, and run it. And so now we have this green highlight on all of the shapes, and you can see we've got a green outline as well as a green highlight. And so we sort of emulated the picking, if you like, with if I equals, say, 1. So we're always going to highlight shape number 1. So we just throw in a like a dummy condition that represents, to do is the shape being hovered. Okay, so there we go. So shape 1, the second shape we draw. So shape 0 is this shape 1, shape 2. And shape 1 is getting the highlight. And we can back that out and get the highlight here and so on. So we want to replace this condition with something. So that's where I handed over to Daniel to come up with sort of the maths behind this. And Daniel, from what I remember, actually took this in a slightly different direction. He's like, well, I've got this calculate separation thing, and rather than just like looking at this and reconstructing the method that I want, what I'm going to do instead is I'm going to just take the whole method and paste another copy, and then edit it to like basically remove the stuff we don't want. So I'll carry down that line of logic, which is what Daniel took, which is actually probably the smarter way to go at this. So we're testing a single shape rather than a list of shapes, and we have a target. So this is the point that's being hovered in the world, and so then we have to go through and figure out what we can remove. So first of all, these two exterior loops can go away. And hopefully I get this right. There we go. And so we have shape A just becomes shape, and we'll fix that. And then shape B has to go away. So shape B, and we sort of had a discussion in this episode about how shape B is basically a circle, and so we're going to use we're going to assume that shape B vertices equals null is true, and the idea was okay, it's basically a circle with radius 0, and so we're going to go through just line by line and just make that happen. So first of all, shape B dot position is going to be the target. So the distance between the position and the target, is it less than, well, combined radius? Now it's got to be just less than shape A radius. I'm going to go ahead and just rename shape A to shape, and then we can get rid of shape A. And so if the distance squared is greater than the radius of the shape, we, instead of continue, we what do? We return false. So already, I should probably rename this. So we had a little discussion about what the best name for this was, and it's like, is clicked and stuff, but actually what we're doing is more along the lines of it's an intersection test. So intersection test, and so we did actually have a discussion. There's many different intersection tests you can do. You can do like square versus triangle, or circle versus circle, or circle versus square, and so on and so forth. Sorry, no, what do we call it? We called it shape point intersect. So we could end up with a whole bunch of methods that end in the word intersect with different arguments, but this is our general shape against a single point. So, and then we return Boolean whether or not it intersected. Okay, so we return false here. Get axes. We got the axes count. Okay, and then get circle axes. So, and then I believe we actually managed to. Oh yeah, that's right. Okay, so if we're going shape versus circle, we're getting circle axes for shape A. So that's just going to be the shape versus the other shape. So this is going to be the shape versus the point. So we've got target here, and we're actually going to make a new get circle axes method. And then we get polygon axes. Now that actually doesn't require knowing about the target, which was shape B originally. It just gets the axes of the first shape. And then we come down here and it's like, all right, we always know that it's going to be a circle. So we know that shape A, we can get the circle axes or the polygon axes, but it's going to be a circle. So it's not going to be a polygon, so that goes away. And we know that the circle axes for a single point, basically we don't need to do corner collisions if the circle has radius 0, because it's always going to collide with the polygon axis. And I don't actually have the whiteboard set up, so I can't draw that, but hopefully that makes sense. Let's see if I can just quickly just wiggle the mouse in the general direction of the solution to this. So if we have a shape like this, you can imagine like a tiny little circle, here is always going to collide. I'm going to draw it a bit bigger than tiny, but always going to collide with this wall. The circle is so small you're never going to get the circle versus the corner. It's always going to be against one of these edges of the shape. So hopefully that quick explanation made sense. So we don't need that code here either, so we're going to get rid of that. Let's see, so separation axis, we actually left these in for a while, but I'll leave them in for now. So then we're doing, we've got our axes and we're projecting onto the axis. So range A is going to be projecting the shape onto the axis, and then project onto axis is going to be the target. So here we've discovered another method that needs a single point projected onto an axis, and in fact range B is probably going to become a scalar, just rather than a range. So then we do so then we're going to do our range test. So while we're here, so let's just think about this. Okay, so if it is inside the range, we immediately want to return true. It's like, if it's not inside the range, we want to return false. And then if it is inside the range, we want to test on all the other axes. So if it's overlapping for every single axis, that means there's no separating axis, therefore it is intersecting. And so basically, you recall that before I deleted that, this code here was did intersect becomes false, so now we're just like return false. So basically in this case it's like, all right, well, we never set did intersect to false, so it's true, so it's basically that becomes return true. So and here we don't actually need to calculate the amount of separation, so it's like, so we managed to get rid of all that code as well. So let's go and make our get circle axes and project onto axis method. Let's just take these up to over here. So we've got project onto axis, and I'll just sort of bang that code in there. First, this is supposed to be float, because we know that projecting a single point onto a single axis will result in a single scalar position on that axis. So we're going to grab this out, and so we can pretend this is again a zero size circle. So we'll get rid of the case for the polygon, and then we have, all right, so we're projecting onto an axis. Circle projection is the dot product of the position, so that's the target, and we know the radius is 0, so it's going to be -0 and +0. So hopefully now you can see why the result of this, A start, A end, min, max, is actually going to be just the circle projection. So circle projection -0 and +0, it just becomes a circle projection, and then we are simply returning it. And that's how we get rid of range, return dot product. And so what we ended up finding was, all right, project onto axis is a single dot product. So we can actually say, all right, we don't actually need a project onto axis method for a single point. We'll just dot product it. So there we go. We'll come back to this line here. Anyway, so the other one we were doing is get circle axes with a single point. And so we're going to come up to get circle axes. And again, we're going to suck out the middle of this method. So this is the approach Daniel took, which is actually a pretty reasonable approach, because we've written this code, and code reuse is good. So and this is how code reuse ends up happening a lot of the time. It's like, well, I've got this thing that almost matches. We're going to edit the code. Code reuse, and I think we talked about this, is very infrequently are you making reusable components in sort of this sort of real world situation. Like by all means, there's good reasons to have reusable components, but a lot of the time when you're actually reusing code, you're grabbing the source code and you're modifying it. That's why you need to make the code sort of easy to modify and understand and simple. So we've got this nice simple method where we're like, all right, well, we know that this is shapes vertices means, because it means that, oh, it's not commented in Daniel's version, but we know that shape vertices equals null means that that the shape is a circle. So we know that. So, and we're pretending that we're going against a 0 radius circle. So we can get rid of the polygon case. And so we're just using the circle. And so we've got the output. We're projecting onto this axis. We're normalizing the shape position versus the other shape position. So that's the target. And so what we can then find is like, oh, this is a single line as well. So this is the approach Daniel took, and it's quite reasonable. And then I just sort of pointed out to him, it's like, all right, you know what we can do? We can actually go ahead and basically copy this whole line. So I actually copy the whole line into here and make sure I get the right method. I think might have been editing the other one, so hopefully I haven't done that too much. So there's no point in having a whole method when we can just be like axes and then axes count, and then we just run over all the axes, you know, and project things back into it. So if it's a circle, we have a single axis, and we're doing basically the line between the two the line between the two circles becomes the axis. In the other case, all of the shape size. So if we've got you know, in this case, this line here is our one axis, so that's content that we did cover. So as you can see, this method becomes really very small, and then all we have to do is like, all right, range B min and range B max are the same thing. So it's actually what do we end up calling this? I think we just call it range B, so we're a bit lazy with that naming, but that's fine. So and then what we did is like, all right, well, okay, well, first of all, no one's using this, and no one's using separation axis. Shouldn't be. I'm not sure why that's not coming up. Hopefully that wind's not coming up too hard on the microphone. I just realized the microphone placement's slightly wrong, but oh well. Hopefully this video is fine. I don't really want to record it a third time. Okay, so we have this arrangement here, and we want to just clean this up. So I'm just going to take a copy of it, get rid of that down there, and we want to invert it. So we're just doing the thing where it's like, okay, not, and then that becomes the sort of the else condition, and then we can do, all right, if we've got a not and an and condition, that becomes an or condition, and the inner ones become knotted. So that's De Morgan's law. The names just escapes me. I think it's that. And then if we have these knots, we can actually change it. So if it's less than or equal to, and this knot goes from greater than to a less than or equal to. And I think that feels like a bug. That feels like I've introduced a bug. Well, maybe not. Oh, yeah, actually. So we had a discussion at some point, and I think it was in one of these videos that we lost. I think I made a mistake there. I can just look at how we made that mistake. And yeah, okay, so so yeah, there's min and max, and we've actually, I think that's yeah, we'll talk about why that's a mistake. So I'm going to rewrite this condition. So one thing we talked about was, I think we had a diagram for this, so maybe this was a different episode. This episode never ended up having a whiteboard. So the way you want to write these range things is like, all right, we want to know if we're outside. So if, and we want to do it sort of, if possible, in a kind of visual way. So you can imagine if this is our point and this is our range of our shape, we want to know if the point is there or if the point is there. So what we end up writing is if range B is less than range A dot min, or range A dot max is less than range B. And you can see it now. I'll try and line these things up, you can see that visually, because we're using less than symbols, and this is why writing conditions in this way rather than these greater than symbols is better, so this should be false, so is because you can sort of think about this visually based on the text. So it's like range B, that's our target that we're checking, projected onto this axis. If it's less than min, so this is min, is part of the shape. If it's less than this thing, it's outside the axis, outside the shape's range on that axis. Or if it's here's max, and its max is less than range B, so it's ordered. You can imagine that I could write this condition as like starting with range B every time, and it would look like this, but then you don't get this nice visual effect. So that's just a handy little trick, and that's good to have. I don't know how I made that mistake before, but obviously that mental debugging trick, it's like, hang on, that doesn't look right. Anyway, so then we can come down here and be like, all right, if I equals 1. So we're going to be if shape point intersect for the shape, and the world mouse position is going to be our target. And then we run it. And what we find is when we hover the shape, we get which shape is being hovered, and it should also work for our triangles and circles, and so this is all working. So that was pretty much everything we covered in that episode. So I think so anyway. We'll just move it to the next episode if not. So thanks for watching, everyone, and I will see you for the next re-recording, and we'll go through what we did next. Cheers.